Good morning to all. Today I am going to discuss about the formal languages and automata theme. Okay, so this is one of the tough subject as we are having in the BTech, but I would like to share my topic here that will be very easy, and I would like to discuss the topics very easily how we are going to solve all the problems in the flat. Okay, so firstly, I am going to start the introduction of the flat here so that you'll be knowing how we are going to create a finite automata and all those things. What are the syllabus we are having here is the syllabus is about the how we are going to get the finite automata, what is the structural representation and automata and complexity and the central concepts of automata theory, and all those things will be in the syllabus of the first unit. How to construct a finite automata, that is the main concept we are going to discuss in the first unit. How to construct the DFA, how to construct the NFA, how to convert from NFA to DFA. All those things we are going to discuss in the first unit. Okay. So in this, I'm going to discuss the introduction to the finite automata. What is meant by a finite automata? So in this, an automata with a finite number of states, okay, is called a finite automata. Okay, in this finite automata, it consists of finite number of states, or we can say it is a finite state machine, which is an abstract machine that has the 5 tuples. So as I told you, this finite automata will be having 5 tuples, and it has some set of states and which is moving from one state to another state. But it always depends upon the input symbol what you are going to give. Okay, so suppose if you are going to have an example, I'm going to mention here. So that is, you are going to have one thing here. So that is college. Okay, so yes, from home, we'll be having 2 states here, happy state and the sad state. So depends upon the mood of the student, we are going to mention the states here. So from home to college, when the student is going from home to the college, the student may be in a sad mode. Okay. So when the student is moving from college to park, the student may be in a happy mode. When the student is moving from park to home, the student may be in a happy mode. Okay, so these are the different states we are having: home, college, park, and S, H are the input symbol. S is a sad, H is a happy mood. These are the input symbols we are having here. And suppose if you are going to take one more example here, from idle state to the running state. Okay, so when it is running state, it is in on input symbol will be given in the running state. When running state to idle state, off symbol will be given. From the idle state to running state, okay, so again on symbol will be given. When it is in the idle state, it is having only off symbol here. Okay, so that is an example I have given here how we are going to take the finite automata. So what is meant by finite automata? It consists of some set of states. Those states are nothing but the finite number of states we are having here in the finite automata. And coming to the structural representation of the finite automata, we will be having some structure of representation in the finite automata, that is series such structure here. Okay, beginning will be one state, and remaining the symbols what we are having, this will be the memory of the state which is limited. Okay, and the input symbol will be there. Okay, so that is dollar here, that will be represented as dollar, that will be the AND state. So whenever you are going to read the data, so that particular data will be sent here by using the tape reading head. Okay, so from the finite control, you are going to send to the this particular input state here. Okay, so that particular input state will be having the beginning state and also the ending state, and in the middle what are the memory you are having, that particular memory will be limited memory. So what is this tape reading head reads the input tape from the left to right. Always the input same, always it is going to read from left to right here. So dollar represents the end of the string here, and pi represents here, that is the beginning of the string. And it has three elements. What are those? Is finite controller, tape reader, and input tape. Okay. So it will be having five elements here. Sorry, three elements here. That will be the finite controller, tape reader, and input tape here. Okay. So in this finite controller, what is finite controller is, it takes the decision making. Okay. So about the input symbol to read and what is the next symbol you are going to receive for a particular input, that will be controlled by the finite controller. What is the tape reader here? It performs the read operation always. One by one, it performs the read operation and reads only one input symbol at a time at a given instance. Okay. So whereas coming to the input tape, it is a sequential tape. Okay, which consists of finite number of cells, where each cell can hold only a single input symbol here. Okay. So that will be a simple introduction to the finite automata. And some central concepts will be there in the finite automata or automata theory here, so that you have to learn that particular symbols what you are having, or learn that particular terminology what you are having in this central concepts of automata theory. Okay, so in this central concepts of automata theory, you'll be having some symbol. What is meant by a symbol is, it does not have any formal definition. Okay, like dot or equal to or something in mathematics we'll be having, no? But in this, we'll not have any formal definition like A, B, 9, 3, all these will be the symbols here. Okay, and coming to the next one, alphabet. So what is meant by an alphabet here? It is nothing but it is a set of finite number of alphabets. It consists of finite number of alphabets or finite number of symbols here. It is denoted by sigma always. Okay. So we are going to mention how many finite number of alphabets are there. Okay. So sigma is equal to 0, comma 1 means it is finite number of symbols. Only it consists of 0 and 1. Suppose if you are having sigma equal to 0, 1, 2 and so on means it consists of infinite number of symbols. That we don't know. You can have any number of symbols. But in finite automata, we are going to mention the finite number of symbols here. So that is sigma is equal to 0, comma 1. So whereas coming to the string, what is meant by a string here? It is nothing but the collection of symbols, which is derived from the single alphabet. So here string is, it is a collection of symbols which is derived from the single alphabet I told you. So what is meant by, it is denoted by W. Okay, so the string in the finite automata will be denoted by W here. Okay, so it is a string, no, so that we can mention it as W/S. So whereas W is equal to 0, 1, 1, 0, that will be a string which consists of zeros and ones. W equal to A, B, B, C. That will be a string which consists of A, B, C. Okay. So W equal to Nrcm. That means it is a string which consists of Nrcm. Okay. So whereas coming to the length of the string, what is the length of the string in many programming languages? You have learned about the length of the string, no? So what is meant by the length of the string is nothing but the sum of occurrences of the symbols in a string is called the length of the string here. Okay, so it is denoted by, string is denoted by W, and the length of the string is denoted by, the length of the string is denoted by W equal to 0, 1, 1, 0 here. So that is, suppose string W equal to 0, 1, 1, 0 means 4 characters are there. Okay, so the length of the string will be 4. Suppose W is equal to epsilon. Epsilon is having the highest priority in the flat. Okay. So W is equal to epsilon I have mentioned here. So epsilon means it is a null string. It is a null string. So the length of the string will be 0 here. So coming to the next one, that is the concatenation of the strings. Concatenation of the strings is nothing but the addition of the two strings. Okay. So here the addition of the two strings which must be added is called their concatenation. Suppose W1 is equal to N, W2 is equal to M, W1 dot W2 will be N plus M. Okay. So that will be the concatenation of the strings. And coming to the null string, as I already mentioned that in finite automata, you'll be having the epsilon as a null string. So as I mentioned that epsilon is having the highest priority. Okay. So always we have to think about the epsilon also whenever you are going to do the problems here. So it is a null string. Epsilon is nothing but it is a null string which is denoted by epsilon E like letter will be there. So it is nothing but an empty string. So that means the no symbols in that particular string. The length of the string is 0. And coming to the prefix. Prefix means pre means before. Post means after. Okay. So the leading symbols of the string is nothing but the prefix. Any length of the string from the left hand side without skipping the symbols in the middle. So in this particular prefix, what we are going to do whenever you are going to calculate the prefixes of that particular string. So W is equal to MAKE. So the length of the string is 4. So prefixes will be first thing is epsilon. We are going to mention always about the epsilon. Okay. So epsilon and first prefix will be M and the next prefix will be MA and the next prefix will be MAK and the next prefix will be MAKE. Okay. So length of the string is N. The possible number of prefixes will be N plus 1. Okay. So if the length of the string is N, so in this example, what is the length of the string? 4. Okay. So what are the possible number of prefixes we are having here? 5. N plus 1. Okay. So coming to suffix. So suffix means the trailing symbols of the string here. Okay. So any length of the string from RHS. Prefix means from LHS. Suffix means from RHS without skipping the symbols in the middle. So what the same example I am going to take here. So that is MAKE I am going to take here. So that will be suffixes are epsilon, E, KE, AKE, MAKE. Okay. So that is from the RHS you are going to do. First thing is epsilon compulsory. The null string will be epsilon and E, KE, AKE and MAKE. From the RHS you are going to do. So here length of the string is N means the possible number of suffixes also N plus 1. So possible number of prefixes is N plus 1 and possible number of suffixes is also N plus 1. Okay. So what is meant by a substring here? It is a string or the part of the string which is obtained by the suffixes or the prefixes or both from the given string. Okay. So that may be suffix or that may be the prefix or both from the given string. So the number of substrings here is any length of the string from anywhere without skipping the symbols in the middle. So the substring can be, you should not skip the symbols in the middle. So MAKE, what are the substrings you are having for the MAKE? Epsilon, M, A, K, E. MAAKKE, MAKAKE, MAKE. So all these will be the substrings. All these will be the substrings here. Okay. So the number of substrings will be always sigma n plus 1. The number of substrings will be sigma n plus 1. So in the above example, what we have taken here? In the above example, what we have taken here, epsilon is one substring, M, A, K, E, M, A, K, K, E, all these are the substrings which we have taken, no? So when the length of the string is n, so the substrings are sigma n plus 1. Okay, so that is substring here. So the types of substrings also will be there, the proper substrings and also improper substrings will be there. Those are the trivial substrings and the non-trivial substrings here. Okay, so coming to the language, what is meant by a language here? It is nothing but the collection of the strings. It may be finite number of strings or infinite number of strings here. So it is denoted by L here. Okay, so here the language is 0, 1, 0, 1, 1, 0, 1, 1. So the length of the language is 4. So here it is a finite language, whereas coming to this, it is an infinite language. So for every finite automata, whatever you are constructing, you are going to take the language there. It is nothing but the collection of strings, which is accepted by that particular finite automata. These language or the collection of the strings may be finite or the infinite. It depends upon the automata what you are going to create. So here coming to the next one, clean closure. So clean closure means what is, see here. So sigma is equal to 0, 1. Okay. So L star or the sigma star will be, or the clean closure. Star is nothing but the clean closure here. So the clean closures will be epsilon 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, and so on. So the language, that particular sigma is equal to 0, 1. So here, what is the language we are going to get for that particular string, whatever you are having? First you can get epsilon 0, 1, any number of zeros, any number of ones, any number of followed by ones, followed by zeros. So that will be the language here. So the closure also the same thing. So the next representation of the finite automata will be continued in the next session.